Okay, I actually have the distinct pleasure and privilege of introducing our last presenter, Emily Mello, who will soon graduate with a master's in physics from the University of New Hampshire and who also has a BS in space physics. You know how people use the expression, it's not rocket science, to say something isn't like the most difficult, complicated, like mind-bending, detail-oriented thing you can imagine? So Emily, who is pictured here holding a photomultiplier about to take some measurements of photons, her whole academic career has focused on doing that most challenging and technical work. And over the summer, I have found that she's incredibly well suited to it. Not only smart and capable, but also energetic and fearless in tackling every challenge. So I'm really excited to share that she's decided she wants to apply those gifts to the field of sustainability rather than rocket science or space post-graduation. And it's with a lot of gratitude and excitement about that future that I now turn it over to Emily.
Thank you, Jen. So I would first like to talk about what is currently reported in a traditional carbon footprint. Most footprinting guidelines only require an organization to report their direct on-site emissions. So for UNH, they would report all the emissions that come out of their cogeneration plant, pictured here on the left. These direct on-site emissions from the cogen plant make up the vast majority of the emissions reported in the UNH footprint. However, this on-campus footprint does not represent UNH's complete carbon impact. On the right here, I have some examples of emission sources that are not currently included in any of the traditional footprinting tools, not even the one used by UNH. These sources include things like the extraction of fuel from the ground or any refining that the fuel needs to go through. All these emissions occur off-site or upstream of where the fuel is used. Calculating the upstream emissions for fuel and energy-related activities is challenging, but that does not mean that it's not important, because accounting for all of our emissions will open the door to countless opportunities for positive change. So we need to start evaluating the parts of our impacts that have previously been left out, which leads me into my findings from this summer. Next slide, please. I have been studying the upstream carbon impact of the use of fuel oil and natural gas in the US. These two graphs here show the comparison between the traditional measurement of impact in blue with the addition of the upstream emissions in orange. By only including the direct emissions, we are underreporting fuel oil emissions by 14% and natural gas by 28%. This is a significant amount of emissions, and this is just for two fuel sources. But what about the other types of energy sources like renewable energy? The total emissions of renewables are smaller than that of fossil fuels, but the indirect emissions will make up a much larger proportion. How much larger? We're not sure yet, which is why, next slide, please. The next step is to continue to evaluate the upstream and downstream emissions from all the other fuel and energy sources. Another really important part of this project's future work will be communication. We need to effectively communicate that the benefits of changing the boundaries to include these indirect emissions greatly outweigh the challenges. We also need to communicate that the fact that while there are no energy sources that have zero impact, by understanding the complete footprint of all of our energy sources, we will be able to make informed decisions about how to best reduce our negative impacts. Now, even if we include these indirect emissions, the measurement of our impact still won't be complete. There are other types of impacts that should be included other than just emissions. These are things like general environmental impacts, social impacts, and health impacts. We can't continue to neglect these in our footprints because by ignoring them, we are missing out on opportunities to make our impact a positive one. And with that, I would like to thank my mentors, Jen and Allie, the rest of the SciMap team, all the fellows, the advisors, and especially the energy group. I'm really, really thankful for this opportunity. I'm not exaggerating when I say it's been life-changing, and I have learned so much that I will be able to take with me for the rest of my career. Thank you.